Hello. This will be the first recording of the recording series for our missing class that you're not going to attend online. We can't hold a class online on the 5th of July, so this will be the first one. So I want us to go back and look at 11.2 dependent sample example. And then we're going to look at the independent sample examples. I want to clarify a couple of things because I think this was the confusing part last time we have seen each other. And then I will solve one, I will give you an outline, the important points of Unit 3 review, and assign you a problem to talk about next time we see each other. So I'm going to take myself off from the video. Hopefully I can do that. No, I cannot. Okay, so we're going to continue like this. So remember the problem Hampton and LaQuantina. So this is a dependent sample, and in dependent samples are match pairs or before and after studies. So in our calculator, the test that we're going to use for dependent samples is one sample t-test. So if you turn on your calculators and if you go to Stat, and move your cursor on the top menu to tests, it's number 2, t-test. So we're going to treat this problem as a t-test because it is a dependent sample. So what we're going to do, we're going to create the column of the difference. So one thing is important here to define your differences. What does difference mean? In this case, difference means Hampton Inn minus LaQuantina. So I created this column by taking the differences of those two values. Okay, it's not writing again. Okay, here it is, right? So this will be the list that we will work. I will enter this list to my calculator as L1, and from this point on, after I enter it to my calculator as L1, I will work it as like a one sample t-test because this is a dependent sample. And after I enter that, I will take the mean and the standard deviation of that list. So if you can go to, again, in your calculator. So let me clarify this. We are going to create that D column, handwritten, and then we're going to enter it as L1. And in this L1, we're going to look at stat, calc, one variable stat, and we're going to get the mean and the standard deviation of this sample, the Neve sample that we get. And so we will be getting those two values. So then by hand calculation, if you prefer, we can find our test statistic. So this was our test statistic formula, right? So D bar will be 51.4. Standard deviation will be 30 point. I mean, you can take 3 places after decimal. It really doesn't matter. And square root of n, because they have the same sample size, I believe we're going to enter 10, right? Again, the key point here, treat it as one sample t-test. Then after we've done all those things, I think we have talked about it in the class. We're going to get a test statistic value 5.2760. Now remember, our hypothesis testing was there is no difference between two hotels, or there is a difference between the hotels. So if the difference is not equal to 0, right, that's our claim. So then that means that we're running a two-test. When we're running a two-test, we double the p-value that we will find. Now, which p-value are we going to find? So here, that's a positive one, right? It's above the mean. So we're going to double that. And what we were doing here, going to two p-value approach. So what is the probability of having these samples like that and more, right? So then p-value will be 1 minus TCDF and double it times 2, right? And I guess our p-value was reading a scientific figure, which was close to this one, which we can do it again together. So follow this comments, if you will. So we're going to go 2 times, and then you need to open parentheses because it's PEMDAS. Then 1 minus TCDF is in the second distribution, and TCDF is number 6. So lower value -1, E99, upper value 527, degrees of freedom 9, because this is a sample size of 10, and close that parenthesis and hit enter. So you should be reading the p-value as here 5.1386 e to the power -4, which means very similar what we the p-value that we are seeing right here. So it means that, come on. All right, so first 0, 1, 2, 3. E to the -4 means that I will have 3 zeros before this value. All right, so this is what we have there very closely. Now, how do we see this p-value? And remember our test statistic, t-test statistic, that was 527. Not by doing any of this, or if you want to verify our result, how does that happen? So then, remember, we had these values, the difference values was in L1. So we're going to go stat, tests, t-test, because that's a one sample test, because we've got this difference column. That's what we're going to choose. You can enter, since we already found those values, var stats, you can use that, or you can use the data. That's completely up to you. And then, so whatever you're testing, if you're using, I'm using the statistics, these values here, 51.4 and 30.8386. So mu sub 0 will be 0. This is what we're testing for. X bar, D bar, serve for X bar, right? And it is 51.4. S sub X, it will be S sub D. Okay, S sub D will be S sub X. That is 30.8336. Our N is 10, and what we're looking for, mu is not equal to mu sub 0. Hit that and calculate. Okay, now it's exactly the same t-test statistics and same p-value we're finding here. Okay, so I guess my confusion or my mistake, if you will, when you're dealing with dependent samples, create this D column, the difference column, treat that difference column as L1, find the mean and standard deviation of this column, L1 column, which starts from 24, 50, 300 and goes to 50, right? Find your test statistic by hand if you want, and find your p-value by hand by using TCDF. That's way one. Way two, again, you have to create this D column, right? And find the mean and standard deviation of this column, or now you can use stat tests, but treat it as t-test use either data or statistics, you will obtain the same values that you have obtained by hand. It is valid for dependent samples. Dependent samples are matched pairs, like in this example, or before and after studies. All right, that's all I wanted to say about dependent tests.